Welcome everyone to the Tulsa.net user group. Tonight, we got Eric Smalling talking about container security. Why should developers care about container security? Eric, thank you so much. I really appreciate you being here. You were recommended by Dwayne, and who spoke at our user group a few months ago and did a fantastic talk. And he said, Eric is somebody you've just got to have speaking here as well. So you came highly recommended. Thank you for being here. Greatly appreciate it. And Eric, I'm going to let you take it away from here.
Well, thank you. I got to remember now to send Dwayne my payment for his commercial for me. But thank you for having me in. And I am here, as you said, to talk about why are these things are supposed to be contained? Why do we need to talk about security? What is it you need to care about? My name is Eric Smalling, as you just said. I am a solutions architect at Chainguard, which is a supply chain security focused company. Actually just started there. I've only been there for about 3 weeks. Prior to that was a developer advocate for Sneak, which is if you've not heard of Sneak, they are a company that does tooling for security for developers. So tooling for scanning your code and containers, whatever. None of this is going to be a vendor pitch in any way, especially not for Sneak, because I don't work there. I've never been in sales. Before I was a developer advocate, I was a professional services consultant at places like VMware and Docker and some small shops in Austin and other places. And before that, I was a software developer, mainly in the travel industry down here in the Dallas-Fort Worth area. I have been using containers since about, and I tell you all this to kind of level set, so you kind of know where I'm coming from. Since about day zero, I think I started in Docker version 0.6 or 7 in 2013. So I've been around them for a long time. There was no orchestrators back then. There was no compose back then. In fact, I can remember when Docker had the how-to to build a container didn't even use a Docker file. So I've been around them a while, and they are not secure by default. I guarantee you that. If you care, I also I'm a Docker captain, so I'm in the group of people who pitch Docker stuff to people all the time. But anyway, and I CKA, CKS, CKAD, whatever Kubernetes certifications. So hopefully I can answer questions as they come up. But let's get into this and talk about container security. If my slides will move, and I promise you this will not all be slides. We will get into some demos. You're going to see why to care about security, and part of that is what can happen if you don't. So the other thing to preface, actually, also, I know this is a .NET group. I am not a .NET coder. I am mostly a Java coder, so you're going to see some Java examples. But hopefully what I demonstrate is, it's general enough that it'll apply across to whether you're watching this and you're a Python coder or Go or whatever. This should all apply across, as long as you're talking about containers. So what are the challenges developers face as we start to containerize our apps and get into orchestrators and whatnot? Well, mainly it's that you have an increased scope of responsibility. If you're new to containers, you're probably not used to some of the operating system level concerns that containing an application starts to expose to you through the Docker file, whatever. Things like file permissions and operating system packages. So most of you are probably using Linux containers, and you may not have used apt or RPM or whatever the tools are. And what are these things? And these are tools that we often have a lack of expertise in, unless you've built your own Linux machines or something. And we've had teams do this for us. We had sysadmins and operations and network security folks and everything else to deal with those things, and middleware teams to deal with our app servers and whatever. Now these things are right next to our code in Docker files and manifests for, whether if you're in Azure, an ARM manifest, or in Terraform or whatever you're using. And then finally, whatever you're doing while thinking about all of this and trying to keep things secure, you need to make sure that you maintain velocity. We, over the years have moved to this fast feedback, agile, get everything through the pipeline as fast as possible. And the business is not going to be interested in slowing down velocity because you want to try some new security tooling or some new security practice. So those are the kind of things we're going to try to get into here. So as we get forward, let's talk about where, kind of narrow down the scope of what we're going to discuss. So what does my app consist of, and what do I need to secure? Well, there's obviously your code. This is some Python code, right? You need to make sure you're writing clean code. You don't want to be writing stuff like and not sanitizing inputs and doing things like that. We know that. We also know that we need to pay attention to the dependencies we pull in. So again, another Python example, if you're using PyPy and you're pulling things in, you need to make sure that there's vulnerabilities in those things. You're getting the updated versions to get past those and know at least that there are vulnerabilities, if there are any, whatnot. Now we have these Docker files. Excuse me. And if you look at this, if you've not seen a Docker file before, this is kind of the canonical way to build an image. This is kind of the lines of definition of what goes into an image, which is what a container is based on. In this case, we're coming from Python 3. Well, what Python 3? What is this? Is this Python 3.1.2? What minor version are we using? What patch version are we using? What exact image could that be? Do we know that tags are mutable and that could actually move on you as new versions of Python come out? Is that important to you? There's all sorts of these questions that start to come up. What is pip and what is celery, pymongo, and bottle? I don't know. Why am I creating a user called Sneaky? So a lot of the content you're going to see here kind of has some sneak stuff in it because that's where I came from, and so my demos have that in it. But just so you know, all that kind of stuff. Then we have IAC. You've got, here's some Terraform, or the granddaddy of all of our container orchestrators, Kubernetes, where the API changes 3 times a year on you, and you need to know, it's enough to get the thing running and working, but keeping it secure can make you hyperventilate. So enough of a kind of level set. Let's get into my demonstration. So let's kind of put on the set of scenario here. So we're a Java shop. And we've got an application. Let me move over to a new window here. It's an old maintenance mode application that we are not really doing much with anymore. We're just fixing bugs on it occasionally. And a long time ago, we did a lift and shift. And I can tell right now I didn't set up. I need to change branches real quick. We did a lift and shift into containers just so we could just deploy it quickly and easily. And at the time we did it, we were on Tomcat 9, and if it ain't broke, don't fix it. So you can see here, this is a Docker file again. This is a multi-stage Docker file, which is, if you've not seen those, this is saying stage 1, I'm going to build my app. I'm using the Java Maven tooling to do this, copy my code in, build the thing up. And then in the final stage, which is in the second stage here, I'm saying from the official Tomcat base image at version 9.0, start from that and then copy all the stuff I built above and some other settings files in, and then run our app. So that's the state. And you can see I have this running in Docker Compose on my machine for simplicity. If I go over to my browser, I can show you that. Refresh the page, make sure that's, of course, oh, I didn't give it the, I have to give it the context here. To-do list. And actually, I just realized something. My demo. I was saying at the beginning, I changed my demo up at the last minute to try something. So if my demo fails, I might have to reset something quickly. Because when you do all these, you get bored, try to make changes. So doing it live. Anyway, so here's my app. I'm not really interested in the app right now. Let me put on my black hat. Let me act like the hacker. And let's say in the morning, I'm reading through, this is the Apache official Tomcat vulnerability fix pages. And then I'm looking at the versions of Tomcat, and I'm noticed that if you go down to the bottom here, in version 9.0.1, they fixed a remote code execution exploit vulnerability. That kind of vulnerability is one where I can, as it says, execute my code remotely on the system that's running this, possibly. Now, I could drill into here and try to figure out how this works, but if I look at vulnerability database for that CVE, that's vulnerability, I could dig in here and try to figure out how it works and get into the bulletins and try to reverse engineer how it does it. But it's old enough that there's a vulnerability exploit database entry for this with a nice Python script that will do a proof of concept. I've taken that and put it behind an alias in another tab here. And let me get in the right directory. Make sure I've sourced it so it's in my path. Okay, so now I'm going to run check. Now imagine I've got some kind of like script going along looking for just open listening ports on the internet. And yeah, I do. I sorry, just a second. Let me fix one quick thing here. Like I said, doing it live. Set this back one. Hard. -1. And we're going to do a Docker compose up and rebuild. Sorry about that. Resetting back to what I showed you before. We're actually on Tomcat 8.5.21. And this is just because I didn't set it all up for Tomcat 9 well enough. So Tomcat 8.5.21, that same vulnerability existed in Tomcat in this version of Tomcat. That's why I had to reset this. So now we come back over here and I'm going to rerun that check script. And it says, hey, it looks like this IP address is vulnerable to this exploit. I come back over and I come in and put in poc.jsp. Oh, refresh. Did I start it? Did it start up? You finish building? Oh, live demos, folks. Always fun. There you go, 8.5.21. poc.jsp. I didn't capitalize the P. Sorry. I guarantee you those A's were not there before I ran that check script. So what happened is that in that Python script, if you were to dig into it, it creates a JSP, a simple Java server page, ships it across the wire through this vulnerable configuration, and injects it into the Tomcat server. So we now have the ability to inject my own thing. Now, A's aren't really, that's just kind of like vandalism, right? That's not really that bad. Well, that script has another side of it, and I've aliased it under pwn, and I just ran that. Now, if I change POC to PWN, I get this nice little form. And if I go in here and let's say host name, I just ran the hostname Linux command inside the environment that this Tomcat server. It shelled out and ran that for me. Let's do, I don't know, who am I? I appear to be root. That's handy. Let's do an ls dash, or actually let's do this, cats etc hosts. There's the host file for this Tomcat server. Now, if you notice from that host name, it's a fairly random thing. This is probably in a container, which, as a hacker, I might not know immediately. But if I do an in env and look at my environmental variables, I could start to see some Docker name things. And yeah, I'm probably in a container. If this was running in Kubernetes, I would see Kubernetes variables like what is my API server from the point of view of this pod? What is my service port that's fronting this if I've got a service? All sorts of interesting information that anyone who's done pen testing or any kind of attack, capture the flags and things, you might have used those to try to get into servers. Well, this is exactly what hackers are using. They're looking at information here. God forbid I put a password or a database connection string in my environmental variables because I've got it now. And now I can start looking for that database and try to connect to it. But what else could I do here? Let's see. Let's see if I can mess with files. Let's create a file under etc called Eric. And then I'm going to do an ls-ltr and etc. And sure enough, there's a new file that I just created called Eric. So I have a writable file system and I can do it as root. One more thing I'm going to check. Let's see. I'm going to do a curl. Let's just go out to the good old Google. I got a 301. That's actually a positive response that's going to redirect me to HTTPS or something. This tells me not only do I have curl at my disposal in my path, I also have network access out towards the internet. So at this point, honestly, I probably am just curling into an S3 bucket or something and grabbing a script that will either help me expand my exploit horizontally in this network, or it's going to maybe just start mining crypto or something, whatever I can, whatever cycles I can get off of this and, earn my 3 cents of crypto or something. Another thing I could do is if I do apt get updates Sure enough, I've got access to some kind of Debian app repositories, and it's going out and getting things. I could install Nmap right now and start poking around the network and trying to figure out what else is running. So I think you get the point. This is bad. Now, hopefully, your network intrusion detection or some other tripwires are being set off and alarms are going off on monitoring, and you're alerted to this happening. But it would be better to catch this early on before we ever got here. So taking off the black hat, let's go back over to our code. And I'm going to fill out of that. And I'm going to stop my Tomcat server. And let's take a look at what we could know about this. So let's imagine you're the developer working on this. You're fixing bugs, and you're going to run a unit test locally. So you're going to build your image to test it locally. Well, but when you do that, and just for sake of time, I've pre-built these. We're going to do a Docker images. Oops, I got a ton of them. Let's do, hold on, cat. Let me look at what I'm calling it, my Docker compose file. I'm calling it Docker Java Goof Ridge. So let's do Docker images Java Goof. By the way, if you ever talk to anyone who's used to work for Sneak or does work at Sneak and they have a Goof named repository and they tell you to play with it, that's fine, but never deploy any of these anywhere that is important. They are full of vulnerabilities for doing these demos, and you will get in big trouble. But you can see down there at the bottom that Java Goof Ridge. This is the one we just ran against, and it is 565 megabytes. And I'm going to run Sneak's scanner on this. Now, again, I don't work there. I'm not partial to them, but I do like one of the things that it does do. So I'm going to do a Sneak container test. And everything I show you is free. If there's anything I show you that's not free tonight, I will let you know about it. But everything I'm showing you is freely available to developers for, you can download it, no credit cards needed or anything. I'm going to do a test, Java Goof, type Goof for Ridge, and I'm going to feed it the Docker file for a little bit of extra metadata since it's sitting right here. And also just to kind of make the output a little smaller, I'm going to say exclude app vulns. That just tells it don't dig really deep into the file system looking for more than just container vulnerabilities. Oops. What did I type wrong? Sneak container test Java Goof Ridge file equal. Well, there we go. So what this is doing, and what all container scanners do, is they go in, they're taking a look at the packages that are deployed into this container. It's taking the Docker file into account so it knows a little bit more metadata about how the image was built. And then it builds a bill of materials. And it either ships it, in Sneak's case, it calls out to a SAS for their vulnerability database. Some of them actually have a cached version of the NVD database they bring down, whatever. Most of these scanners, if you've used them before, you're probably used to getting a big long list or a spreadsheet of vulnerabilities, and they may tell you interesting information like, hey, this critical vulnerability was fixed in curl version X, so upgrade that. But what I like about some of them, like Sneak's, is that it'll come down in the summary and say, hey, did you know that you are based on Tomcat 8521, which has that base image brings to the table 735 vulnerabilities. 70 of them are critical. Now, anyone who's done Java work or Tomcat and worked with Tomcat knows that's a hella old version. One of the reasons there's so many vulnerabilities is because it is so old. And there are much newer versions. And it's actually telling you that. It says, hey, if you would just update your base image to 8598, you would drop to 29 total vulnerabilities, none of them high or critical. If I was really crazy, I could go into these alternatives and get into using the Amazon Corretto JVMs and get down to 0 vulns. Now, imagine as a developer, again, I'm talking about people who are new to containerizing. I may not understand a lot of this. I may what do you mean? I'm not a middleware guy. I don't know how Tomcats compare. I'm not a container person, really. I don't understand all these different packages. But I have usable information that I can take and have an educated discussion now with my lead, my architect, my appsec folks, and say, hey, this looks bad. We should probably look at this. And I'll put my architect hat on, be like, oh yeah, we could go to 8598, which is, I believe, the latest 8.5, and then we could take a look at what these other CVEs are and if they're important. We could probably even go to 9. Our app is probably compatible with that. Not ready to drink the Amazon Kool-Aid and go to Corretto yet, but let's go ahead and, for sake of argument, let's go to 9085. I'm comfortable with that. So if I open my code back up, change this to, now I could go to 9085, or I could go to 9. And in Docker Hub, the 9 tag is usually a latest version of 9. Either way works. I'm just going to do that just for simplicity, for make it easy to read. And then we'll come out here, and I'm just going to tell Docker Compose to clean out what we had before and rebuild from the Docker file that's sitting here. And it should be cached, so it shouldn't take too long. There we go. If I come back to my browser, I refresh, that'll be gone because we've cleaned it out. But if I go back to 8088, that's normal because I didn't give it the context. There's my app running. If I go to the exploit now and try to recheck it, not there. And that would have been true if I had gone to the latest version of 8 or 8.5 or 9. Well, I know my app doesn't run under 10, so I didn't go to try to look at any of the newer versions. But now the hacker just moves on. So by simply scanning, it's taking the extra minute or two to scan your image as you're working on your, before I've even committed my code, I've headed this off. As soon as there's a CVE known, you're going to get alerted to it as soon as you do the scan. There's other ways you can do scans. A lot of the tools like Sneak and others you can have it monitor your images. So even if you haven't made a change to an image, it'll let you know via email. Sneak will actually open a pull request on your Docker file if you have it, set up correctly. So you wake up in the morning and you either have an email or maybe a pull request in your Git repository with a nice formatted, hey, here's the problems that we found in this image. Here's some fixes for them, and you can review them, take them if you want to. If we were to run the Sneak scan on this, you'd see that there's a lot less vulnerabilities in it. Now, that being said, I don't want to make this sound like it's a Sneak ad. This is, so if you've used Docker Desktop before, you might have seen the latest versions have something called Docker Scout. This is their scanner. It operates in a little bit different. It's not actually doing the same kind of scans that most like Trivy or Gripe or Sneak do. They are in the background storing SBOMs for everything and then comparing those against the NVD National Vulnerability Database. So if I come in here and I do the same kind of a scan against one of these, I'll just do this one 900 that's sitting here. You can see it's giving similar kind of information. It's saying there's all these vulnerabilities. And if I want to, I could ask it for recommendations, and it's going to tell me same kinds of things. It's like, hey, you kind of have to tell it which version of 9 you're on. But Docker Scout, it's nice and speedy and fast, same kind of information, but use something. If you're building an image locally for your testing, scan it while you got it, and take action on it if it looks bad. Now, that being said, what happens when there's a CVE, when there's a vulnerability that we don't have a CVE for? Or what happens if I don't catch one of these things? Well, there's practices that you can do. You can practice defense in depth. And when it comes to containers, that falls under usually 3 categories: your images, the runtime environment you're running them in, the settings you have for the containers, and then Kubernetes-centric things that we'll talk about. So the first thing under images, minimize footprint. So when you saw what I was doing there, you saw that if you looked closely in my images, you'll see that I've got some that are tagged slim, and there's one tagged CG for Chainguard. These images, when I was testing, you saw I had curl at my disposal. There's all sorts of tools in there that you don't need. The default Tomcat 9, I think it is, image that is just Tomcat 9 ships with the kitchen sink in it. It's got a ton of things developers might need for fun for iterative development work, but for production, you do not need all that stuff in there. And by eliminating having it in there, it just removes tools for a hacker to use against you. There are versions of the images like slim tagged versions that, in the case of Tomcat, if we go back again and look at this, you'll see that this built on top of a 9 Slim image, still Debian. It's still the same base, operating system distribution, but it drops the size of the image by, what is that, 140, 150 megabytes, because they're putting less in it. And less in it is less things that people can use against you. There are other strategies. There is something called distroless images, which are images that have nothing in them but the binaries you need to run whatever it is you're asking for, Node, Java, whatever. There aren't many middleware type, like Tomcat style distroless images. But my company Chainguard does have some, and we have a bunch of free ones. If you go to images.chainguard.com, you can take a look at them. So for instance, you've got we're going to stick with the Java thing. We could do JDK, and we'll look at the JDK. So the free versions of the images we provide, the latest build of everything that we have is available for free. So you could do the latest version of Java, and there's 2 versions. There's a latest and there's a latest dev. There's also dot versions of older ones that are available on the paid tier. That's one of the things that isn't available for free. But if you were to use one of those, since my app won't run on the latest version of Java, I tried building it with the Chainguard Tomcat 9 version. That dropped my size down another 200 megabytes. And this is because Chainguard's images are much like the distroless. In fact, they're based the same. The guy who created distroless at Google he's one of the founders of Chainguard. These images have what we call an undistro. It's called Wolfie, is the open source project. And it is a distribution. So in these images, instead of having a full kernel and everything you would have to, like if you were going to deploy to a server, or all the other libraries you would need for a full distribution, they carve all those out. And we just have just enough to run Tomcat in this case, the JVM, the supporting libraries, and the Tomcat app server. And it's all rebuilt from source with attestations and all the SBOM stuff that your security teams want. So take a look at Wolfie, take a look at Chainguard if you're interested in that. But by doing that, you minimize footprint, you reduce the number of things that people can get at. You also need to understand how image layers work. So let's say I wanted to make sure curl wasn't, I don't want to use a distroless or a Chainguard image. I want to use the main one, but I just don't want curl in there. Well, if you just simply do a Docker file run remove curl, yes, that will remove it from the visible file system at the time the process runs. But if somebody accidentally were to bind mount in a volume from your host and they could get to wherever your container runtime engine is storing layers, it's still there. It's kind of like a Git repository where everything is there and it's just the deltas between layers or between commits in Git. Well, between layers in a Docker image, it's just the deltas, right? So the code is still there in the earlier layers. Plus, you're carrying around a bunch of stuff you don't need anyway. There are multiple different kinds of build strategies. You saw multi-stage build being used here. It's nice for having that final stage being very terse. So if you need a fat stage, like I had the Maven stage for building, I don't need Maven or my source code in the final build. So I was dropping down to the Tomcat one. This is a .NET meetup, so there are .NET runtime images and .NET development images, things like that. There are other build strategies. If you are a Java shop, I'm actually a big fan of not using a runtime engine to build anything. I use Jib, which is an open source project that builds OCI compliant images without needing that. You can use it from Maven or Gradle from the command line. Just needs a Java engine. Go developers, there's one called Ko, that does the same thing. It's a Go implemented image builder that just, instead of typing Go build, you type Ko build. I don't know if there's one for .NET. Would be cool. If there's not, you should make one for the open source community. And there's cloud native build packs. There's all sorts of different ways to build your images. If you're a Red Hat shop, you're probably using Builda. Understand how your build tools work and use them correctly. And then finally, supply chain. You knew I worked for Chainguard. I'm going to talk supply chain, but in this case, there's entire conferences dedicated to supply chain, so there's no time tonight to go into the weeds on this. But my main point here is you need to make sure you know where your images are coming from, and they need to be coming from an auditable source with attestations about how they were built, signatures, and all that good stuff. Specifically, you do not ever want to deploy an image that Eric built on his laptop anywhere you care about, because you can't audit that. You have no idea what's in there. It should be coming from a managed registry, whether that be in the cloud that your cloud account that you're dealing with, or in a private registry maybe that you're managing, or even if it's a public one, it needs to be in a private, paid, managed area that you control. Never be deploying straight out of public things that you don't have control of, because you have no idea what could have been injected into them. Now, when we get to runtime, there are things like don't run as root. And we joked at the beginning about containers being secure by default. They're not. And because I was root in that example, I could do things I couldn't do if I wasn't. So let's say using apt-get to install nmap. I could have proceeded and done that, but I couldn't have if I wasn't root in there. Not easily, at least. Also, if somebody does accidentally bind mount a volume from your host into the container and you're UID 0 in that container, you now are UID 0 outside, unless they're really advanced and they're using user namespaces, which I've not seen being used in the field much at all. Most people are running just standard Docker or containerd or cryo, and as soon as you are root and that volume gets mounted in, you can read write whatever you want in there if it's not mounted, if they're not taking precautions. So don't run as root your application, especially if you're running business applications. They don't need to be root. Yeah, so don't. Privileged containers, this is kind of an easy one because by default, this is turned off. Privileged containers are the runtime giving host access to devices into the process that's in the container. I actually talked to Jerome Peterzoni, the author of this flag on Docker, the command line, and he said when they wrote it, they wanted to call it dash, instead of dash dash privileged, they wanted it to be dash dash insecure, because it literally turns off all, it's giving you control of everything. Most of you are never going to run this way anyways. The only time this really becomes a problem is a developer, maybe in Kubernetes, turns it on to try to get something working locally because they can't figure out what the permission they need is, and they forget. And they check that manifest in, and then it goes out. And if you don't have checks or balances to stop that, you just don't want to do that. The one that people don't count on is privilege escalation. This is the SUID bit, right? Sudo. If this is not blocked by default. If you are deploying a pod in Kubernetes and somebody is able to get an image in there that has sudo or another binary that has the privilege escalation bit set, they'll be able to run it unless you explicitly say Kubernetes security context, no privilege escalation. It's unfortunate that that's the default, but it is, and it is simple to become root if you know how to get an image in, especially if network. They can get out to another registry to pull down an image and get it in there. You saw that I was able to create a file in etc. That's because we had a read-write file system. When a container starts, the container runtime engine, takes all those read-only layers that are part of the image, kind of sandwiches them up and presents a file system, but it adds one more layer before it starts the process, and that's a read-write layer. And any mutations happening in the file system are happening there, outside of any other volumes you're mounting it. And it does a copy on write, right? So it's if you don't need mutation, if you can be immutable, run with a read-only root file system. It just won't create that read-write layer, and now it makes it a lot harder for a hacker to download a script in there, to modify configs in your app, to modify binaries in your app. None of these are silver bullets, but all of them make life harder on the hacker. And they'll move on to an easier target if you have enough of these set up. And then kind of on the same lines, as I said in the images with secure supply chain, don't be deploying from unknown sources. Don't be, know where your images are coming from. And we get to Kubernetes. So we talked about secrets before the call started. And Kubernetes secrets, if you have credentials, if you have sensitive things that are properties for your application or configurations for utilities or whatever, you need to be storing them in secure fashion. Never put them in the image. Just never. Just like you wouldn't put them in a Git repository. Same reason. Never put them in a config map, because a config map is just a name value pair. There's no encryption or protection really on that. Don't put them in files, property files, and attach them, which is a very common practice in the Java world back in the day, when you would just make a Catalina properties file and stick your connect string in there. Use some kind of secrets management. Now, if you are already using something like HashiCorp Vault or CyberArk or whatever vendor's secret system, and your company supports it and understands it and is comfortable with it, continue to use it, because they're great. Kubernetes can be configured to store its secrets in those things, and you should. If you're not, and you're just using Kubernetes secrets raw, make sure whoever your cluster admin is has set up encryption at rest for those secrets, because otherwise they're in etcd base 64 encoded. And if I can get access to the file system that etcd is sitting on, I can get access to all your secrets, the entire cluster. So just be aware of those things. But the reason secrets are there is because they are a separately controllable role-based access control resource. So you can say service accounts X, Y, and Z can access, read these secrets, as opposed to the config map and other things that you get at, so that you're able to segregate them away. But just make sure you're doing it right. Which brings us to RBAC, role-based access control. Use it. It's not much to say there. RBAC has a high learning curve for a lot of developers as you're getting started, because it's not intuitive really. But once you grasp it, it's not too bad. It just I can't say much more about it other than learn it, live it, love it. It's part of the world in Kubernetes. The security context I touched on a second ago. This is the API on the pods and containers to do a lot of the things we just talked about in the runtime state and more. There's actually a blog that my colleague and I wrote back a couple years ago on like the 10 most important ones of these. I will share it in the chat later when I finish here. But it goes into kind of the high level of what are all these security contexts and how do we use them. Things like making sure your process, the container process doesn't start as root. Kubernetes can be told the kubelet won't even start the container if it's going to start as UID 0 or if it doesn't know. You can turn off Linux capabilities. So if you're a business app, you probably don't need to be making low-level system calls into the kernel to do network manipulations and things. So drop capabilities, drop those out, deny them all, drop them all, and then just add back just the ones your application needs if it does need any. So network policy. This is one of my favorites because most of us as developers, we've had a network team that does firewalls for us. We don't do that. We tell them, here's what our application needs. We open a FAR or whatever you call it at your company, and they open a firewall access request and they get it done. Well, moving into the cloud, a lot more developers have had to deal with it because you know, in AWS, you have your security context. No, security, my mind's gone. You know, the security stuff for network. Network policy is that for Kubernetes. It is a micro-segmented firewalling system, but it's really actually pretty simple. It's just a YAML file that says what can or can't talk to each other. And I'm a fan of starting with deny all, zero trust. The only thing, maybe DNS, because you have to have that for service discovery, but nothing can talk to anything. And then as I add pods to my deployment, you know, my deployments and whatever, I start opening up and creating the allow lists of things that I want. I want my front end to talk to my back end, that direction on port, you know, 1, 2, 3, 4, whatever. And then I want my back end to talk to the database only on this. And you set up all your labels, and it makes it very easy to stop a lot of things in their tracks. For instance, we remember Log4Shell. If you're a Java shop, you remember that. That was a little bit over 2 years ago. And it was basically the Log4j library had the ability to use an external LDAP directory to pull configurations down, but somebody figured out, oh, hey, I can just throw an interpolated string with a JNDI string in there, and I can go talk to my LDAP server out at, you know, ericsdarkweb.com or whatever. And instead of returning a directory entry, I'm going to return effectively a path to a class file. And that bytecode will just come in and just get executed in the JVM. If you had network policy in place, there's lots of ways you could try to fight Log4Shell back before there was a fix for it. But if you simply just had network policies keeping things from calling out to the internet and calling to things that weren't expected, that would have changed that remote code execution exploit into maybe a denial of service, because, you know, the Tomcat threads might start to spin up if people start really machine gunning you with it. But network policies are really, they're not hard, and they're easy to implement. And once you get to know them, they're actually a good thing to know. And finally, enforce all these things with some kind of admission controller. So we've talked about a lot of different ways at runtime and network policy to do things. But if you're not making sure that the policies your team has are being implemented, that they do you no good, really. You need to make sure that when I deploy to the cluster, there's something checking that. Now there's Kyverno, which is a very popular one that allows you to write these policies in Kubernetes custom resource definition, so the YAML that you're familiar with. OPA with their gatekeeper admission controller that uses a Rego language, which is very powerful. And a lot of people know OPA from other. It's not just a Kubernetes thing, so you can use that. And a lot of tools use Rego for their policy type things. And in fact, built into Kubernetes since what was it? 1.25 is I think is when they sunset the old pod security policy, which was the kind of the security context watchdog. They replaced it with pod security admission, which is a lot simpler and allows you to say, hey, restrict this namespace. Don't let anything in here that doesn't match the restricted policy. And a lot of this stuff is covered by that. And then you can tweak it up and cover it as well. So finally, takeaways, make sure whatever you're doing, whatever tooling you use, whether it's Sneak or Docker Scout or Gripe or whatever, it gives you a fast feedback loop, gives your developers a fast feedback loop. Because if you choose a process or a tool that takes an hour to run or overnight to run, they're not going to do it. So you want to give developers, empower them with fast feedback loops and give them tools that allow them to be proactive. This is why I like Sneak. This is why I like Docker Scout, is it's giving me information that says, hey, not only here are the spreadsheet of CVEs you need to fix, you bad developer, it's, hey, they're coming from your base image. Just upgrade your base image. Tools like Chainguard images, where they Chainguard images, if you're not aware of them, they aim for 0 CVEs. So they rebuild everything from scratch and they patch things multiple times a day to start you at 0. That's their goal. And then finally practice these things, these defense in depth practices. That's all I have. I don't have a clock in front of me. I have no idea if I've gone over. I get to talking.
I had a question. So you were talking about Chainguard. They basically like rebuild all the base images, nuke out all the stuff that's vulnerable that probably nobody uses anyway. Like,
Yeah.
so there was one this week. It was, I can't remember what it was called. It was like Priz CLI or some cert. There was some CVE that hit every image this week
Yeah.
that we had to update. And so what you're saying is like Chainguard has their own like OpenJDK 21 Slim, whatever.
Yep.
You know. Gotcha.
Yep. So for instance, if we look at JDK, come in here, you see that there's several different JDKs. There's, if you just want to stick to LTS, there's that one. There are FIPS variants. These I think are only in the paid tier because we have to do a lot of work to try to get FIPS compliance. But like the JDK developer, the latest and latest dev are available for free. And if you just use that image instead of the whatever other one you're using, you'll get that one. And it is guaranteed to have 0 or near 0, depending on the image. I mean, some of these things, it's hard to get them down to 0, but it's the most minimal amount of vulnerability you can get. And there's some blogs out there, if you go to the Chainguard blog, that's quite interesting how they get at that. They actually, like for I know for Go and Java, they're rebuilding the JDK from source, which is not easy with the JDK because you have to go back, one builds on the other, and you have to go back in time and get to have the source from JDK, 1 dot whatever, and rebuild everything all the way forward. And they have all of the chain of custody and attestations for all of that.
Okay. What's the I was just thinking of something that was a follow-up question to that. Is it just things like JDK, or do you actually repackage things like Mongo or Confluent or things like that?
Yeah, it's growing all the time, so it's hard. And I'm only 3 weeks with the company, so I don't. But yes, we do have MongoDB. We have the Bitnami flavor of MongoDB if that's what you're using. Again, a FIPS version. But yeah, there's all sorts of stuff. Again, if you go to images.chainguard.dev and go into this directory, you can see there's developer tooling. There's clear that. There's base images. There's Kubernetes specific things. One of the things I know they added recently that a lot of people were really excited about was Istio. So if you deploy Istio service mesh, there is a Chainguard version of it.
Yeah, I see they've got RabbitMQ also. Interesting.
There you go. Okay. And again, I don't want to be pitchy. I'm not here to pitch my company.
Well, but I mean, the fact that there's a free tier is encouraging. So.
Yep. And again, the only difference between the paid tiers and the free tiers are things like FIPS compliance, if we're doing the extra work to do that. Or if you want to be able to, the free one is always going to be latest. It's a rolling latest. If you want to be able to say, I want version at this time, and not do your own management of that, then that's a paid service because it's our registry. You're paying for
Yeah,
registration.
no, that absolutely makes
Yep.
sense.
And there's also some learning as I go and as I get into this company. You can go and take a look at vulnerabilities and then where they are in the different images we've had and how they've been fixed and what's being done with them. All sorts of cool stuff here. Any other questions? I'm sorry, I haven't watched the chat. Is anything in chat I need to be looking at?
The only other question I had was at the beginning of the session, you were talking about, God forbid you put a password in an environment variable. And I guess my question around that is, it seems to me like even when we put stuff in Kubernetes secrets, that like the apps pull them through environment variables.
And that is a common, I call it an anti-pattern, but it is a common pattern that applications want them in environmental variables. More and more applications, though, that I've seen, the open source applications have moved to allowing you to specify a path on the file system. So you use the other flavor of the secret mounting and let it read it right from the file system. But I honestly, as a pragmatic,
now that's the other way I've seen it as well, is basically it's like a dot properties, but it's stored in Kubernetes secrets and it's mapped as like a mount in the file system.
Yeah, it's in a tempfs read-only RAM disk basically, and it's formed as the pod comes up, and as the pod's destroyed, it goes away with the RAM. But I'm still a big fan of, if your application's already using Vault or whatever, just continue to do that. That's even better in my opinion. What I'm not a fan of is coding your app to be Kubernetes
aware.
You want to tie yourself to your platform,
or even worse, Azure Key Vault aware or some
whatever.
Other thing.
You want to make sure you're flexible enough to, if you have to be moved to something else or a new version comes out, that you're not going to pin yourself to a version because I can't get off of Kubernetes 1.21 and it's end of life. What do I do?
Right. Okay, good. Thank you.
I'm going to stop my screen share so you're not.
Well, you're good. All right. That was good talk. I really appreciate that, Eric.
I had a specific question that is, I don't know if Eric would know the answer to this. Maybe some other people have some thoughts. I've been looking into the Microsoft, equivalent of the Slim, the distroless, whatnot images, and I'm wondering if anyone has any thoughts on Ubuntu Chiseled versus the CBL Mariner distroless. Anyone tried those, played with them?
I'm very curious to hear the answer because I've not looked at them myself.
Party of one here. Okay.
Well, yeah, Randy, hit me up though. I know a guy over at Microsoft that might know the answer to that, because that is his day job, is working with the container images, and .NET and etc.
Yeah, I have a new thing that's not in production yet, and I'm running .NET 8. I've got it in the CBL Mariner 2.0 distroless. But it's the special one that has the extra, which is the TZ data, because we do need that. And it's a very special purpose piece. So so far so good. It works, and it accomplishes many of the things Eric just talked about, because there is no package manager. There's no you're not running as root. And in fact, when I scanned that, after I tweaked some of our packages, I've got 0 CVEs.
Nice.
And of course, you do have to, for this particular image, you do have to build your .NET app at self-contained, which is fine with me. I don't care. But there's nothing. There's literally nothing coming in the image. The image has never heard of .NET. So it's just a Linux image.
Probably better.
Yeah, and I think the Ubuntu Chiseled is exactly the same. I just I've only got so many hours in the day, so I kind of flipped a coin and picked one.
I'm going to put another blog here in the chat that's Matt Moore, who's the creator of Distroless, who's our CTO. He just put out, it goes into kind of the history of Distroless and how it was, the genesis of it, and how, how Chainguard images compares, Wolfie and all that. Chris asked, is Alpine better now? I stopped using Alpine's fine. The biggest complaint about Alpine, and this has been since as long as I can remember, is it's not glibc. So if you're doing anything on an older app that needs binary compatibility with glibc, you're going to be, that's not going to work. Like I would run into people who always wanted to run OpenJDK Alpine because it was small and whatever, and then all of a sudden they realize, oh crap, my app has an old JNI call for some reason, and well, sorry. I know that I'm not a JavaScripter, but I know that the Node community has kind of shied away from Alpine in the last couple of years because Node does not consider the Alpine base image official. So you're not going to get much support if you have an issue and you open one. It's going to be kind of best effort. And my fellow Docker captain, Brett Fisher, who's a big Node guy, is kind of he moved away from recommending that the Alpine image for that reason. But I have no positive or negative otherwise.
I think it was the culture things that I had problems with, and why I stopped using them. Switched to something like Ubuntu Beatbox or some.
Yeah.
Who knows?
Yeah, I don't have a dog in the hunt. When I worked for VMware, we were not allowed to talk about Alpine because they were BusyBox based, and BusyBox had a lawsuit with VMware, and that was.
Gotcha.
Yeah, we were using we were looking up language codes, and we were using oh crap. The fat version of Linux. Oh crap, I'm drawing a blank. And we moved to Alpine because security was all freaking out about like all the stuff we had installed.
Yeah.
And we lost. Yeah, that's what we lost. That was the biggest thing is the language codes. So.
And with
the Wolfie
7.
Oh, sorry, go ahead.
I was gonna say with .NET 7, when Microsoft gave you the Ubuntu 2204 images, the TZ data package dropped out.
Oh.
So even though they were saying here this is ready to go, it wasn't, and they actually changed that with 8. Now those are not the chiseled the things we've been talking about here. Those are the big fat ones.
Yeah.
But they learned from that, and they now assure you that when you get a .NET 8 installed image from them, it will have TZ data, because that freaked a bunch of us out. It's all one day we're going, hey, let's try 2204 instead of.
That's what it was. It was the time zone stuff. That was a nasty one.
Well, yeah, you're going, hey, we'll just flip to the latest Ubuntu. It's like, splat. No,
yeah.
I mean, it's easy enough to fix, right? But
right, you just add it. Yeah.
And so anyway, they've learned, and now if you get a fat one from Microsoft, it will have TZ data. I saw that little comment go by. It's kind of a oops, sorry guys comment.
Question about Wolfie. So Wolfie, as I mentioned, that's the open source project. That's what they call the undistro, which is the base for all of the Chainguard images. That is named Wolfie after. So Chainguard's mascot or logo or whatever is Inky, the octopus, and the Wolfie octopus is the world's smallest octopus. So,
oh, good to know. Interesting.
Yep.
There's
so
always something.
I thought it was a cat that just had octopus arms.
That's GitHub.
Yeah, that's the Octocat.
Yep. Which my daughter, when she was much younger, the first time she saw a sticker with that on, she called it Catapus. I was like, that's a better name, actually. I like that one.
Yeah, I'm thinking I know why they didn't pick that one.
Yeah, well. The Wolfie is interesting because some of the creators of Wolfie are Alpine maintainers, and it uses APK, but it is all glibc compiled. I think they actually, if they haven't released yet, I think they were talking about actually having a choice where you could have Mussel and whatever Mussel or glibc, but it's all glibc right now. The idea with if you read that blog that I put in there for Matt, it's interesting. The concept of Wolfie and the Chainguard images that use it is, instead of building up your images with just random run lines in Docker files, you use APKO, which is a tool for taking packages and they will source build in and build your image declaratively instead of imperatively like the Docker file does.